Good morning, students. So, today's topic of online video series is Introduction to CNN Layers. As I had already discussed about convolutional neural network in my previous video, and in that video I have given a brief idea about how convolutional neural network works with its layers. So in this video we will discuss how these layers will actually work. In this video we will discuss and we will see each and every layer of CNN with details. So the first layer is basically CNN contains 4 layers: a convolutional layer, ReLU layer, pooling layer, and a fully connected layer. So let us see about first convolutional layer. Students, a convolutional layer is a layer of machine learning which helps a machine to extract the important features of any image. What I mean to say is that if we can put any image into machine, then how it can identify and match with its already saved database by extracting the important features or main features of an input image, as it is written also here, like it is the first layer to extract features from an input image, and it preserves the relationship between pixels by learning image features using small squares of input data. Suppose we can say that this is the pixelated image of our given input of image. Okay, so how a convolution layer extract any particular feature from that input image by doing some dot product with the help of this filter matrix. Students, filters, as we had already discussed in our previous online video of CNN, that filters are of many kind, and each and every filter will extract different features one by one from the image. So how it can extract? Basically it can use a dot product, and by applying this dot product it can create a new matrix or a new array which is called convolved feature. Okay, so students, as you can see, if I can put this small matrix over this pixelated input image, then after performing dot product, like how it will performing 1 into 1 plus 0 into 1 plus 1 into 1, then again this 0 plus 0 into 0 plus 1 into 1 plus 0 into 1, and likewise 1 into 0 plus 0 into 0 plus 1 into 1. So when we put this filter on the image, on the pixelated image, then it will gives you this kind of convolved feature, or this will become the output after convolution layer. So students, this is the example how it extracts the features of any pixelated image one by one, and this is the matrix which it has formed. It shows the extracted feature property of a feature of one feature of an image. Okay, if we can take out, as you can see in this, in this picture, what you can see like if this is the input image, then it can extract its corner part. It's a picture of car, and it is extracting a patch from an input image, and then it convolution layer reduces its dimensionality by doing this dot product, and likewise after it gives its output to further layers which will come after this convolution layer. So what I am trying to say in this, convolution layer is the layer which is used to extract the main features of any input image and gives output to its oncoming layers by reducing its dimension. Okay, so the objective of convolution operation is to extract high level features such as edges from the input image, and its need not to be limited to only one convolution layer. Conventionally, the first conv layer is responsible for capturing the low level features such as edges, gradient, okay, etc. With added layers, the architecture adapts to the high level features as well, giving us a network which has the wholesome understanding of images in the dataset, similar to how we would. So there are two types of results at the end of this operation we will get. One is called convol feature in the form of reduced dimension as compared to the input, and other is the dimension or other in which the dimensionality is either increased or remains the same. So this will create, or this will gives, basically after convolution layer, the kind of output we will get in the form of reduced dimension. And what are the advantages of this reduced dimension? See, if we have only important features to make any image understandable or to find out any image, then it is easier for any machine to process it. To make it easier for processing, a convolution layer reduced a dimension of a patch which we have taken from an image. Okay, so likewise a convolution layer works, and it is not limited to only one layer. Convolution layer can work in there may be various convolutional layers works with the same architecture and for the same image. Fine. So for each and every patch there will be the process like convolutional layer 1, convolutional layer 2, convolutional layer 3, and it will work until and unless the complete feature or all important features will get extracted. Fine. So now after convolution layer, our second layer will be activation layer. See students, as we had already discussed in our class, and the details of this activation layer I had discussed in the lecture which I had attached in my LMS account, so you can go through that. But here what we can discuss the role of activation layer. See students, convolution layer works or gives a linear fashion operation, but here what a machine is supposed to perform with all non-negative values or with non-linearity. Okay, so how we will achieve this non-linearity? We will achieve this non-linearity with the help of ReLU function. Okay, the full form of ReLU is rectified linear unit for a non-linear operation, and it is introduced non-linearity in our convolutional network because the real world data would want our convolutional network to learn would be non-negative linear values. You know what is the meaning of linear operation? Like it works in a sequential manner. This is called linearity, but sometimes it is required that leave some information and just focus your point on some important parts of the picture to find out that whether this picture belongs to that particular category or not. So what we need in that, we need non-linear fashion operation, and this will give best by ReLU, rectified linear unit. This is a kind of activation function which gives or which converts all negative values to the positive one. So likewise we will achieve our non-linear fashion operation. After this activation layer, we will be having pooling layer. Students, as in many architecture description, it is saying that the pooling layer is completely optional. Like if you need it, then you can apply it. Otherwise, it is not at all needed. Why so? Because it also works very much similar to the convolutional layer. Like it is also uses to reduce the size of inputs and hence speed up the computation. Okay, but if you required, then you must know about its functionality. Pooling, as I explained, that as I said, that it is used to reduce the size of any input. Okay, so how it reduces? Basically, students, it uses to extract the dominant feature. Okay, and how it gives like this, extracting dominant features which are rotational and positional invariant, thus maintaining the process of effectively training of the model. So how it does? Basically, pooling is of two types. Fine. Max pooling and average pooling. So if we can provide the pixelated image to the machine, it does either max pooling function or average pooling function. How it does the max pooling function? See, on the basis of the filter size, we can divide our matrix into various parts. For example, if this is the convolve feature, or if this is the feature map, then here four places are there, and if it needs only four values, so we have to divide our whole matrix into four parts. So in our first part, if we apply max pooling, then what we are supposed to do, we are supposed to put the maximum number of all these squares. Like here if we can see, the 6 is the maximum value, so here we can put this, and by looking this area we can find that this 8 is the maximum one, and here this 3 is the maximum one, and here 4 is the maximum one. So likewise we get our convolve feature, or we get our feature map. Fine. So this is the output which this is the reduced output, reduced dimension output, which we will found after applying this max pooling function. So likewise we can also apply average pooling, or sometimes at some places we can perform sum also of all these numbers of this area. Right. In average pooling we will take the average of all these four numbers. So likewise we will get our reduced image. Fine. Now the last and the most important layer is called fully connected layer. This is the layer where all the extracted features, output images has been present. Okay, and from all these extracted important feature images, it will identify, or it will gives the output like this, whether it belongs to this category or to this category. It gives the output in the form of various classes. Fine. So whatever class percentage matches with an input image will become our answer. Like here what we can see, this may be the input image, then after extracting its important features, what we will get the answer in flattened form, in a flattened array form, and from this flattened array it will decide that the feature which all these neurons are given matches 0.95 with dog and 0.05 with cat. So what will become the output? That yes, the image which we have inputted into the machine will become more likely a picture of a dog. So This is the decision, or this is the operation which may perform by a fully connected layer. Students, in a neural network, all inputs from one layer are connected to every activation unit of the next layer. And the most popular machine learning models, the last few layers are fully connected layer, which compile the data extracted by previous layers to form the final output. It is the second most time consuming layer, second to convolutional layer, and it is a regular neural network layer which takes input from the previous layer and computes the class scores and outputs the 1D array of size equal to the number of classes. Fine. So likewise this layer performs. Students, about this layer I had given complete details in my notes, again which I attached with the LMS, so you can go through it. And one assignment also I have given, and you can perform that assignment and submit it to me till 2nd of April. And if you find any query regarding this CNN introduction and its layers working, then you can ask from me either through mail or through my number. Thank you.